2023, edit. In February 2023, a further problem of an analysis error by a supplier related to the 787 forward pressure bulkhead was identified, leading to a further temporary halt in deliveries, but not in production, and a 5% drop in the company's share price. On the 10th of March, the FAA approved the resumption of the deliveries. 2024, edit. In April 2024, Boeing engineer Sam Salepour reported that the 787S, as well as the 777S, fuselage had been improperly assembled and that it could cause individual aircraft to break apart in midair. Salepour also claimed that he tried to raise these concerns to Boeing but was reprimanded by the company. The FAA is investigating Salepour's allegations. Boeing released a statement rejecting these claims. Design, edit. The Boeing 787 Dreamliner is a long-haul, wide-body, twin-engine jetliner, designed with lightweight structures that are 80% composite by volume. Boeing lists its materials by weight as 50% composite, 20% aluminum, 15% titanium, 10% steel, and 5% other materials. Aluminum has been used throughout the leading edges of wings and tailplanes. Titanium is predominantly present within the elements of the engines and fasteners, while various individual components are composed of steel. External features include a smooth nose contour, raked wingtips, and engine nacelles with noise-reducing serrated edges, chevrons. The longest-range 787 variant can fly up to 7,565 mi, 14,010 kilometers, 8,710 mi, or the even longer Qantas QF9 flight between Perth and London Heathrow, over 7,828 mi, 14,497 kilometers, 9,008 mi. Its cruising airspeed is Mach 0.85, 488 kn, 903 km per hour, 561 miles per hour. The aircraft has a design life of 44,000 flight cycles. Flight systems, edit. Among 787 flight systems, a key change from traditional airliners is the electrical architecture. The architecture is bleedless and replaces bleed air with electrically powered compressors and 4 of 6 hydraulic power sources with electrically driven pumps while eliminating pneumatics and hydraulics from some subsystems, for example engine starters and brakes. Boeing says that this system extracts 35% less power from the engines, allowing increased thrust and improved fuel efficiency. Spoiler electromechanical actuators, SEMAs, control 2 of the 7 spoiler pairs on each wing surface, providing roll control, air and ground speed brake, and droop capabilities similar to those provided by the hydraulic actuators used on the remaining spoiler surfaces. The SEMAs are controlled by electronic motor control units, EMCUs. The total available onboard electrical power is 1.45 megawatts, which is 5 times the power available on conventional pneumatic airliners. The most notable electrically powered systems include engine start, cabin pressurization, horizontal stabilizer trim, and wheel brakes. Wing ice protection is another new system. It uses electrothermal heater mats on the wing slats instead of traditional hot bleed air. An active gust alleviation system, similar to the system used on the B-2 bomber, improves ride quality during turbulence. The 787 has a fly-by-wire control system similar in architecture to that of the Boeing 777. The flight deck features multifunction LCDs, which use an industry-standard graphical user interface widget toolkit. Cockpit display system interfaces to user systems /ARINC 661. The 787 flight deck includes two head-up displays, HUDs, as a standard feature. Like other Boeing airliners, the 787 uses a yoke, as opposed to a side stick. Under consideration is the future integration of forward-looking infrared into the HUD for thermal sensing, allowing pilots to see through clouds. Lockheed Martin's Orion spacecraft will use a glass cockpit derived from Honeywell International's 787 flight deck systems. Honeywell and Rockwell Collins provide flight control, guidance, and other avionics systems, including standard dual head-up guidance systems. Thales supplies the integrated standby flight display and power management, while Meggitt /Securaplane provides the auxiliary power unit, APU, starting system, electrical power conversion system, and battery control system with lithium cobalt oxide, LiCu2, batteries by GS USA. One of the two batteries weighs 28.5 kilograms and is rated 29.6 V, 76 Ah, giving 2.2 kilowatt-hour. Battery charging is controlled by 4 independent systems to prevent overcharging, following early lab testing. The battery systems were the focus of a regulatory investigation due to multiple lithium battery fires, which led to the grounding of the 787 fleet starting in January 2013. A version of Ethernet, Avionics Full Duplex Switched Ethernet, AFDX, /ARINC 664, transmits data between the flight deck and aircraft systems. The control, navigation, and communication systems are networked with the passenger cabin's in-flight internet systems. In January 2008, FAA concerns were reported regarding possible passenger access to the 787's computer networks. Boeing has stated that various protective hardware and software solutions are employed, including air gaps to physically separate the networks, and firewalls for software separation. These measures prevent data transfer from the passenger internet system to the maintenance or navigation systems. The 9/10 hybrid laminar flow control, HLFC, system delays the critical transition from laminar to turbulent flow as far back as possible on the vertical tail by passive suction from leading edge holes to mid-fin low-pressure doors, but was dropped from the tailplane due to lower benefits than the extra complexity and cost. Airframe, edit. The 787 is the first commercial aircraft to have an airframe majority made of carbon fiber reinforced polymer, CFRP, applied in the empennage, fuselage, wings, doors, and in most other main components. Each 787 contains approximately 77,000 pound, 35 T, of CFRP, made with 51,000 pound, 23 T, of pure carbon fiber. CFRP materials have a higher strength-to-weight ratio than conventional aluminum structural materials, which contributes significantly to the 787's weight savings, as well as superior fatigue behavior. Historically, the first CFRP primary structure in Boeing commercial aircraft was put into service in 1984 on the horizontal tail of the Boeing 737 Classic, and in the mid-1990s on both vertical and horizontal tail, empennage, of the Boeing 777. In the early 2000s, while studying the proposed Sonic Cruiser, Boeing built and tested the first CFRP fuselage section for commercial aircraft, a 20-foot, 6.1-meter, long anechoic chamber, which later applied to the Dreamliner. Instead of designing one-piece composite fuselage barrels like the 787, the competing Airbus A350 uses a slightly more conventional approach with CFRP panels on CFRP frames, which is considered less risky in terms of assembly tolerance between fuselage sections. Safety can be a concern due to lower impact energy absorption and poorer fire, smoke and toxicity capability of CFRP fuselages in the event of a crash landing, leading to whistleblower complaints at Boeing by Vince Weldon, who was fired in 2006. The Occupational Safety and Health Administration, OSHA, later denied Weldon whistleblower status largely on the grounds that Boeing's 787 design does not violate any FAA regulations or standards. Boeing further argued that CFRP structures have been used on empennages and other parts of airliners for many years without incident, and special damage detection procedures will be instituted for the 787 to detect any potential hidden damage. In 2006, Boeing launched the 787 Gold Care program. This is an optional, comprehensive life cycle management service, whereby aircraft in the program are routinely monitored and repaired, as needed. Although the first program of its kind from Boeing, post-sale protection programs are not new. Such programs are usually offered by third-party service centers. Boeing is also designing and testing composite hardware, so inspections are mainly visual. This reduces the need for ultrasonic and other non-visual inspection methods, saving time and money. Interior, edit. The 787-8 is designed to typically seat 234 passengers in a 3-class setup, 240 in 2-class domestic configuration, and 296 passengers in a high-density economy arrangement. Seat rows can be arranged in 4 to 7 abreast in first or business, E.G. 121, 222, or 232. 8 or 9 abreast are options in economy, E.G. 242 or 333. Typical seat room ranges from 46 to 61 in, 120 to 150 centimeters, pitch in first, 36 to 39 in, 91 to 99 centimeters, in business, and 32 to 34 in, 81 to 86 centimeters, in economy. Cabin interior width is approximately 18 feet, 550 centimeters, at armrest level. The Dreamliner's cabin width is 15 inches, 38 centimeters, more than that of the Airbus A330 and A340, 5 inches, 13 centimeters, less than the A350, and 16 in, 41 centimeters, less than the 777. The 787's economy seats can be up to 17.5 in, 44.4 centimeters, wide for 9 abreast seating and up to 19 inches, 48 centimeters, wide for 8 abreast seating arrangements. Most airlines are selecting the 9 abreast, 333, configuration. The 787's 9 abreast seating for economy provides passengers less space, particularly across the hips and shoulders, than any other jet airliner. Some observers recommended passengers avoid flying 787s with 9 abreast seating, although others suggested that the 787 is more comfortable than other airliners. The 787's cabin windows have dimensions of 10.7 by 18.4 in, 27 by 47 centimeters, and a higher level so passengers can maintain a view of the horizon. The composite fuselage permits larger windows without the need for structural reinforcement. Instead of plastic window shades, the windows use electrochromism-based smart glass, supplied by PPG Industries, allowing flight attendants and passengers to adjust 5 levels of sunlight and visibility to their liking, reducing cabin glare while maintaining a view to the outside world, but the most opaque setting still has some transparency. While the lavatory window also uses smart glass, it was given a traditional sunshade. The 787's cabin features light-emitting diodes, LEDs, as standard equipment, allowing the aircraft to be entirely bulbless. LED lights have previously been an option on the Boeing 777 and Airbus aircraft fitted with standard fluorescent lights. The system has 3 color LEDs plus a white LED. The 787 interior was designed to better accommodate persons with mobility, sensory, and cognitive disabilities. For example, a 56 by 57 in 140 by 140 centimeters convertible lavatory includes a movable center wall that allows 2 separate lavatories to become one large wheelchair-accessible facility. The 787's internal cabin pressure is the equivalent of 6,000 feet, 1,800 m, altitude, resulting in a higher pressure than for the 8,000 feet, 2,400 m, altitude of older conventional aircraft. According to Boeing, in a joint study with Oklahoma State University, this significantly improves passenger comfort. Cabin air pressurization is provided by electrically driven compressors, rather than traditional engine bleed air, thereby eliminating the need to cool heated air before it enters the cabin. The cabin's humidity is programmable based on the number of passengers carried and allows 15% humidity settings instead of the 4% found in previous aircraft. The composite fuselage avoids metal fatigue issues associated with higher cabin pressure and eliminates the risk of corrosion from higher humidity levels. The cabin air conditioning system improves air quality by removing ozone from outside air and, besides standard HEPA filters, which remove airborne particles, uses a gaseous filtration system to remove odors, irritants, and gaseous contaminants, as well as particulates like viruses, bacteria and allergens. Engines, edit. The 787 is powered by 2 engines, which use all-electrical bleedless systems taken from the Sonic Cruiser, eliminating the superheated air conduits normally used for aircraft power, de-icing, and other functions. As part of its Quiet Technology Demonstrator 2 project, Boeing adopted several engine noise-reducing technologies for the 787. These include an air inlet containing sound-absorbing materials and exhaust duct cover with a chevron-toothed pattern on the rim for a quieter mixing of exhaust and outside air. Boeing expects these developments to make the 787 significantly quieter both inside and out. The noise-reducing measures prevent sounds above 85 decibels from leaving airport boundaries. The 2 different engine models compatible with the 787 use a standard electrical interface to allow an aircraft to be fitted with either Rolls-Royce Trent 1000 or General Electric GEnx 1B engines. This interchangeability aims to save time and cost when changing engine types, while previous aircraft could exchange engines for those of a different manufacturer. The high cost and time required made it rare. In 2006, Boeing addressed reports of an extended change period by stating that the 787 engine swap was intended to take 24 hours. In 2016, Rolls-Royce began flight testing its new Trent 1010 engine. It has a new compressor system based on the compressor in Rolls-Royce Trent XWB engine and a new turbine design for extra thrust, up to 78,000 lbf, 350 kN. Rolls-Royce plans to offer the 10 on the 787 to 8, 9 and 10. In early 2020, of 1,484 orders, 905 selected GE, 61.0%, 476 selected RR, 32.1%, and 103 were undecided, 6.90%. 1. GEnx 1B nacelle. 2. RR Trent 1000 nacelle. Operational history, edit.